Dear students, in this class, let us discuss about a new term, that is Diophantine equation. What is a Diophantine equation? Diophantine equation means an equation solved in integers. An equation solved in integers is called a Diophantine equation. So for example, consider y square equals x cube plus k, which is a Diophantine equation. So we know that the general theorem states that y square, the Diophantine equation y square equals f of x has at most a finite number of solutions if f of x be a polynomial of degree greater than or equals 3 with the integer coefficients. The general theorem states that the Diophantine equation y square equals f of x has at most finite number of solutions when f of x be a polynomial of degree greater than or equals 3 with the integer coefficients. Now, in the next theorem, we try to show that an infinite set of values of k for which y square equals x cube plus k has no solutions. That's our next aim. So, the corresponding theorem states that consider the Diophantine equation y square equals x cube plus k. The theorem states that the Diophantine equation y square equals x cube plus k has no solution if k is of the form k equals 4n minus 1 whole cube minus 4m square, where m and n are integers, such that there is no prime p which congruence to there does not exist a prime p such that p congruence to minus 1 mod 4. This is our theorem. The theorem says that the Diophantine equation y square equals x cube plus k has no solution if k is of the form 4n minus 1 whole cube minus 4m square with m and n are integers, such that there exists no prime p with a p congruence to minus 1 mod 4 that divides m. Okay, how to prove? So the proof is done by contradiction method. If possible, there exist x and y such that this k congruence to minus 1 mod 4. K means here p is the prime. So if possible, there exists x and y are the solutions such that k congruence to minus 1 mod 4. K congruence to minus 1 mod 4 means from here, what is k? Y square minus x square. So that means y square minus x square congruence to minus 1 mod 4. Okay. Y square minus x square congruence, y square minus, not x square, x cube, sorry, y square minus x cube congruence to minus 1 mod 4. That means y square congruence to x cube minus 1 mod 4. Means there exist two solutions x and y such that which satisfies this condition, y square congruence to x cube minus 1 mod 4. We assume there exist two solutions x and y which satisfies this condition with the k congruence to minus 1 mod 4. But instead of k, here it is y square minus x cube. So means there exist the solutions x and y with the y square congruence to x cube minus 1 mod 4. Okay. Now we know that we have y always congruence to y is either, for all y, either y congruence to 0 mod 4 or y congruence to 1 mod 4. That is true for every y. Okay. not a y square. Y square for every y, this is true. Y square congruence to 0 mod of r or y square congruence to 1 mod of r. Why? When y equals 0, 0 congruence to 0 mod of r, y is 1. So 1 also the congruence to y is 2 square. Okay, so when either y square is congruence to either 0 mod of r or it is 1 mod of r. When y is 1, what happens? Y square is congruence to 0 mod of r. Listen, you have any doubts? If suppose y equals 0, what do you get? 0 congruence to 0 mod of r. Is it true? Okay. When y equals 1, what do you get? 1 congruence to also 1 mod of r. Sure. When y is 2 square. What is 2 square? 2 square also congruence to 0 mod of r. When y is 3 square means 9 congruence to 1 mod of r. And so on. Okay. So means y square is either congruence to 0 mod of r or it is congruence to 1 mod of r. That is true for every y. Agreed? Okay. Now, if x is even, what happens? If x equals 2k, x is even. When x is even, what is x cube? X cube. X cube equals 8k cube. Agreed? 8k cube. So 8k cube is always congruence to 0 mod of 4. Sure? 8 is a multiple of 4. So when x is even, x cube is always congruence to 0 mod of 4. Agreed? But what is y square? Y square is congruence to 0 mod of 4. X cube is congruence to 0 mod of 4. So what do you get? Y square minus x cube also congruence to 0 mod of 4 in first case. Sure. Y square congruence to 0 mod of 4 and x cube congruence to 0 mod of 4. So y square minus x cube also congruence to 0 mod of 4. Again, y square congruence to 0 mod of 4. Y square congruence to 1 mod of 4 and x cube congruence to 0 mod of 4. Also, you have y square minus x cube also congruence to 1 mod of 4. Enough. So, combines either y square minus x cube congruence to 0 mod of 4 or y square minus x cube congruence to 1 mod of 4. Agreed. Now, if x is even, x equals 2k or 2 lambda, whatever may be, 2k1 or 2 lambda, whatever may be. Or if x congruence to minus 1 mod of 4. X is even or x is congruence to minus 1 mod of 4 means satisfies this condition. Why? Because we assume that x and y be the solution of k congruence to minus 1 mod of 4. Agreed. So when x is even and x is congruence to or x is congruence to minus 1 mod of 4, then what is y square? Then y square is congruence to x cube minus 1 mod of 4 will not satisfy. Sure? Yes. When x equals 2k, what is 2k? X is even. 8k cube. 8k cube is always an even number. Even minus 1, odd number. So y square congruence to an odd mod of 4 is impossible. Agreed. When x congruence to also minus 1 mod of 4, so y square congruence to x cube minus 1 mod of 4 does not satisfy. Clear? Yes. Now, when x is even and x is even means what is x equals 2k. So what about x cube? X cube congruence to 0 mod of 4. Sure. X is even, then x cube congruence to 0 mod of 4. And suppose y square, if y square congruence to 0 mod of 4. There are two conditions. Y square either congruence to 0 mod of 4 or 1 mod of 4. First we assume if x is even and y square congruence to 0 mod of 4. X is even means x cube is also congruence to 0 mod of 4. Like this. Okay. And if y square congruence to 0 mod of 4, y square congruence to 0 mod 4 means 4 divides y square. Agreed? 4 divides y square, and x cube congruence to 0 mod 4 means 4 divides x cube. Therefore, 4 divides x square and 4 divides x cube. If y square congruence to x cube minus 1 mod 4, if y square congruence to x cube minus 1 mod 4, that means yes, 4 divides y square minus x cube plus 1. Clear? But 4 divides, here it is, 4 divides x cube. 4 divides x cube and 4 divides y square. That combinedly gives 4 divides y square minus x cube. Sure? Okay. And 4 divides y square minus x cube and 4 divides y square minus x cube plus 1. So that gives 4 divides 1, which is impossible. 4 does not divide 1. 1 is not a multiple of 4. So 4 does not divide 1. That's a contradiction. Hence, so means it is impossible. So if y square congruence to x cube minus 1 mod 4, then we have a contradiction. Agreed? Now, so when x is even and y square congruence to 0 mod 4, the case is impossible. Consider another case. If x is even and y square congruence to 1 mod 4, what happens? If x is even and y square congruence to 1 mod 4. Y square congruence to 1 mod 4 means 4 divides y square minus 1. Sure? 4 divides y square minus 1. Again, x is even means what is x cube? We know that x cube congruence to 0 mod 4. That means 4 divides x cube. Agreed? So, if possible, y square again, if in this case, if y square congruence to x cube minus 1 mod 4, that means again 4 divides x cube minus, 4 divides y square minus x cube minus 1. Here 4 divides y square minus 1 and 4 divides x cube. So what I get? 4 divides y square minus x cube, 4 divides y square as minus x cube plus 1. That means 4 divides y square, okay, minus x cube minus 1 plus 2. Clear? This 4 divides, listen, 4 divides y square minus x cube plus 1 can be rewritten as 4 divides y square minus x cube minus 1 plus 2. Sure? Okay. But listen, 4 divides x cube and 4 divides y square minus 1 means 4 divides y square minus x cube minus 1. So from here you have 4 divides 2, that is, which is also impossible. So this case also does not hold. We see that when x is even and x cube when x is even and y square congruence to 0 mod 4, then y square congruence to x cube minus 1 mod 4 is not possible. Also, even x is even and y square congruence to 1 mod 4, and if then in that case also y square congruence to x cube minus 1 is also mod 4 is not also possible. So these two cases does not hold. Clear? Okay. So the cases are y square congruence to 0 mod 4, y square congruence to 1 mod 4. Here we use these two conditions. When x is even and y square congruence to 0 mod 4, we see that this case does not exist. Also when x is even and y square congruence to 1 mod 4, also we see that that case also does not hold. Okay. So these two cases does not hold here. Now again, consider also you consider if x congruence to minus 1 mod 4, if x congruence to minus 1 mod 4, why? Because x and y satisfies the condition a congruence to minus 1 mod 4. Okay. So if x congruence to minus 1 mod 4 and y square congruence to 0 mod 4, what happens? Consider these two cases. if x congruence to minus 1 mod of 4 and y square congruence to 0 mod of 4. So, y square congruence to 0 mod of 4 means we know that 4 divides y square. Clear? Okay. X congruence to minus 1 mod of 4. X congruence to minus 1 mod of 4 means x cube also congruence to minus 1 whole cube. That is again minus 1 mod of 4. Clear? Okay. So, x cube congruence to minus 1 mod of 4 means 4 divides x cube plus 1. By x cube plus 1 congruence to 0 mod of 4. That means 4 divides x cube plus 1. If possible, if y square congruence to x cube minus 1 mod of 4, that means 4 divides, that means 4 divides y square minus x cube plus 1. Okay, so listen, what is 4? 4 divides y square. Okay, so but we have 4 divides y square gives 4 divides minus x cube plus 1. 4 divides minus x cube plus 1, that means 4 divides x cube minus 1. Okay, okay. By multiplying minus 1. So 4 divides x cube minus 1. 4 divides x cube minus 1 means 4 divides x cube minus 1 plus 4. Sure. If x cube minus 1 is a multiple of 4, then you add that x cube minus 1 with the 4, that number is also a multiple of 4. So 4 divides x cube minus 1, that should imply 4 divides x cube minus 1 plus 4. But 4 divides x cube minus 1 that means 4 divides x cube minus 1 plus 4, that means 4 divides x cube minus 1 plus 4. That is plus 3. So that 4 divides x cube plus 1 plus 2. That 3 can be rewritten as it is 4 divides x cube plus 3. Okay. That gives 4 divides x cube plus 1 plus 2. Agree. But 4 divides x cube plus 1. 4 divides x cube plus 1. So 4 divides x cube plus 1 plus 2. That means 4 divides 2 again, which is impossible. So that is impossible. Hence this case is also does not hold. If x congruence to minus 1 mod of 4 and y square congruence to 0 mod of 4, then if y square congruence to x cube minus 1 mod of 4, then again that case does not hold. We have a contradiction, 4 divides 2. One case also remains there, but which is that if x congruence to minus 1 mod of 4 and y square congruence to 1 mod of 4. Okay, if x congruence to minus 1 mod of 4 and y square congruence to 1 mod of 4, what happens here? So, x cube congruence to minus 1 mod of 4, x congruence to minus 1 mod of 4 means x cube also congruence to minus 1 mod of 4. Clear? So that means 4 divides x cube plus 1. Sure, x cube plus 1 congruence to 0 mod of 4. Also y square congruence to 1 mod of 4 means 4 divides y square minus 1. Clear? Okay. If possible, y square congruence to x cube minus 1 mod of 4, what happens? If possible, y square congruence to x cube minus 1 mod of 4, that means 4 divides y square minus x cube plus 1. Okay, that is 4 divides y square minus 1. You can introduce minus 1 and plus 1 minus x cube plus 1. Sure? Okay. That means 4 divides y square minus 1, y square minus 1, then minus x cube plus 2. But what is 4? But 4 divides y square minus 1. That means 4 divides y square minus 1 minus x square minus x square is plus 1 plus 3. Okay, that means 4 divides y square minus 1 minus of here x cube plus 1 plus 3. But why 4 divides x cube plus 1 and 4 divides y square minus 1? So from here 4 divides 3, which is again impossible. So these 4 cases are does not hold. Means when x is even and y square congruence to 0 mod of 4, that case does not exist. When x is even and y square congruence to 1 mod of 4, case does not exist. When x congruence to minus 1 mod of 4 and y square congruence to 0 mod of 4 does not exist. And when x congruence to minus 1 mod of 4 and y square congruence to 1 mod of 4, also we get a contradiction. Okay. Therefore here x congruence to minus 1 mod of 4 does not be possible. Therefore x congruence to 1 mod of 4. Agreed? Okay. Now in the expression k equals, listen. Now consider k. What is k here? Here k is of the form 4n minus 1 whole cube minus 4n square. Agreed? So consider the expression k equals 4n minus 1 whole cube minus 4n square. Okay. Let a equals 4n minus 1. Let a equals 4n minus 1. Therefore what is k? Therefore k equals a cube minus 4n square. A cube minus 4n square. Therefore what is y square? Y square equals k cube plus, x cube plus k. X cube plus k. That is x cube plus k means y square equals x cube plus a cube minus 4m square. Clear? So that means y square plus 4m square equals x cube plus a cube. What is a cube plus b cube? It is a plus b into, means x plus a into x square plus a square, a plus b into a square plus ab plus b square. So it is x square plus, a square minus ax. X square plus a square minus ax. X plus a into x square plus a square minus ax. But what is a? We have a equals 4n minus 1. A equals 4n minus 1 means a equals, come to the equality, a equals 4n minus 1. That means what is a? A congruence to minus 1 mod 4. Okay? A plus 1 is 4a. That is a plus 1 is a multiple of 4. That means a congruence